So yeah, so my name is Jeremy Zerr. So Andrew Chumich over there. So we are Zerr Tech, two of us. So what we have is we wanted to start and get a bit more experience with React and Redux. We do a lot of, so we have a small web shop. We do a lot of client work in front-end development stuff, and probably the most experience in Angular. Probably the last 2 years have been almost like 95% of our work is in front-end is Angular. So we wanted to take this as a chance to kind of, it's not always opportunities there for us to experiment with new stuff on client work, because that's bad juju. So we want to make sure that we take our time and start learning at some of these different things so that we're prepared when like other client projects come up to be able to offer, have a good perspective on different design patterns and stuff out there. So what we wanted to do with this was, we've been doing work for T-Sheets, building some time tracking apps, and everything that we've been doing has pretty much been in Angular. We have some other stuff that's just kind of without a framework right now, but a lot of Angular. So in trying to evaluate a framework, you could have just picked in just like some random application, but I was like, well, why not try and build a similar thing to what we've already built in Angular, and then build it in React and Redux, just to have a chance to see, what things are harder, what things are easier, which, just to understand, like, because like all of us, we want to know and understand on a project, like what's the best choice, what's the best framework to use, and to not have to like spend months, figuring that out before we do it. So that was kind of the main reason, like get some extra experience and like building something that we had kind of built before, not to the depth that we've done for the client work, the paid client work, but kind of just seeing it there. So what we built with this, it's just a time tracking app based on their API. So there's no real local storage or anything like that, no IndexedDB or anything storing stuff locally. So it's out there on GitHub, and we're actually going to be continuing developing on this, and probably hoping if it works out and people are interested in it, that we'll kind of recurringly present a little bit on this project as it becomes more complex and we encounter different things. So what we wanted to do today is just sort of present sort of where we're at and a few of the things that we've learned so far. We have things that we've done that we're not presenting tonight, but that we're probably going to present next time, because we wanted to kind of slice it up and not just present for, 2 hours trying to talk about a project. So as far as the presentation goes, just like a brief intro to React and Redux. How many people here have written code in React and Redux? Okay, how about Angular? Okay, good, because I wanted to, because one of the reasons I'm doing this is kind of have a comparison to Angular. I'm going to sort of bring in some Angular things that this in React and Redux would be similar to this in Angular. I hope that's useful. It's useful to me because like there's some things in Angular that we're like, I don't like how that ever works, but then in React and Redux it's completely different, and maybe it's better, maybe some things are worse. So do that for you guys. But basically, just go over a little bit about React and Redux. I'll keep it quick, since about half of you, I think, have done React and Redux before. Go over some terminology, some common stuff in case you aren't familiar with it as we go through the rest of the talk. There's just things that you don't really think about. What we wanted to do is sort of go through our process of designing the application. Like our steps, like figuring out what we wanted to build, then modeling our state, and then designing the actions and reducers that we wanted to take that state to mutate it to something else, and then taking those states and mapping them to the components that we're actually going to make. So like an actual step-by-step. So it's essentially what we did when we built this thing. So and switch elements in and out. So that's kind of their, claim to fame or revolutionary kind of concept that they kind of brought to the JavaScript framework world, which a lot of people are now like really embracing and copying and mutating their frameworks. So the other thing is that sort of along with that virtual DOM and the computation is the one-way data flow. So when Angular came out, we were all like, oh, two-way data bindings, this is so cool. So we're like, we were skiing last week. Snowboards were cool too. So now it's like cool to go skiing. So like you go back to classic. So now everybody's like, no, two-way. It's all one-way, man. So one-way data flow is what you get with React, and we have a little diagram to kind of go through what exactly that means. But yeah, things go in and out of style. I don't know if I don't think Angular's out of style, but it's just funny how it's like a revolt against, oh, you did two-way, we're gonna go back to one-way. So we'll check it out. So basically, this one-way data flow leads to pure functions. So pure functions being that everything that you need in the function is passed in the function signature, and it returns and just something, and doesn't do anything else, doesn't mutate things all over the place, just what you see, and you're explicitly saying what goes in, and you're getting what comes out, and nothing, no other side effects happen of the function. And it only calls other pure functions that would do the same, have the same type of, yeah. So when you have pure functions, of course, as you can imagine, debugging is a lot easier and testing is a lot easier. Because if you know everything that you're explicitly saying is going into this function, you can test all the possible combinations and you get what you got out. You don't have to worry about, well, what's the state of this dependency? Let's make sure we mock that and set it to some good known state before you call this function. And then you have to know so much stuff about it. So really, it's you know, we all could be designing our code like that, anyways, right? But this is sort of a you know, like a lot of these frameworks, it's all about what is it encouraging you to do, and it's usually a better design pattern than what we had before, or you know, maybe bring some weaknesses or some laziness. I know I get lazy doing stuff in Angular. It's too easy to just, you know, do stuff everywhere. So, and then you'll see component markup built in JSX. So like, I know that's another thing. We all got away from like having JavaScript in our, or like HTML code in our JavaScript. That was like the first thing that we looked at our code from the late 90s and early 2000s, and then puked all over it when we saw it. But so now you sort of have JSX that's like bringing back having markup inside of your JavaScript, but you can separate it out into a file. But you know, just like everything, when you see examples of a new framework out there, you go out and you see, well, how's somebody going to give me an example of a one, you know, something that can fit in a little text box? Well, they're going to put the JSX inside. They're going to put everything inside. They're not going to modularize it until you get to a big project. So we'll see that. And then it's sponsored by Facebook. There's actually several, well, they've been snapping up, like the guy who made Redux, he's a Facebook employee now, I think it sounds like. Yeah, so just acqui-hire, but you didn't have a company, so I don't know how that worked. I'm sure they're just like, here's $1 million. Okay, so what is Redux? So Redux doesn't need React. Redux can work on its own. They're essentially two separate things, but one of the things that is kind of a, you know, like I said, the Redux is the view for sure, a little bit of the controller. There's no model, there's no state. They kind of imply, like if you go look at their documentation, it'll be like, well, so what do you do with the state now? Well, you could do one of these 5 things. So they don't, you know, they're not like, oh, you should use Redux, or because that's the beauty of it, I guess. You know, you have these smaller components, these smaller projects you can cobble together. So you know, there's several alternatives. There's Flux, and then probably one of the more popular ones besides Redux, but Redux has kind of taken off and been this crazy whirlwind of a thing. So what Redux does is manage state for a web application, which React components then render that state. So the React components being view and the state model all stored kind of with React. React has a system around it. So one of the central things is a single data store for the state for your app. So you have one place to go. With Flux, there's a lot of different stores, and I think the Redux thing was like, well, why don't we just make it one store? So kind of simplifies things. You got one place to look, and then you can add, so that really you can add a lot of, or sort of reduce a lot of complexity around having to manage a different store than just have one store. So that's one of the big concepts. Kind of getting to some of the terminology, your application emits an action that defines something that just happened that will affect the state, and then you have reducers that describe when that action happened, how should it change the state from the current state to the next state, given the arguments from the action, whatever it happens. So, you know, rudimentary, just like click a button, that's an action. Applies, dispatches, gets to the store. There's a producer that says, well, I know how to reduce that action down to, I'm taking the arguments from that click. If there was like a button special name for it or whatever, take the state, change it to another state, and then that's your, so kind of a, kind of emphasis on functional style programming is you can kind of get with the whole, you know, React, pure functions and things. So it's kind of get back at that, you know, is what is, again, what is old is new and is cool, old functional. So I want to ask Andrew about closure script. Lisp and all that fun stuff too. Talk about that later. So one of the other cool things, essentially why Redux was started is the Dan Abraham was kind of looking for a way to make it so that you could have a great developer environment while you were coding something. So having a single state and having that state being tracked as it's mutated and as it's changed by all these actions, because as you can think, you have just a list of these actions that are coming in, and the state changes from one to another. So what you'll see as we go through the demo is that the developer tools that you get, you can see all those states that are, as they're applied, in this little developer tool thing that kind of is one of the pretty common packages to use. So you can sort of see what was the state before, what's the state after. So it's not like stuff you have to make. It's just output in a nice little window on the side, not in the debugger like in the Chrome DevTools, but actually like a little sidebar type thing. So that's one of the awesome parts. It's been pretty cool to have that as a tool in addition to having your developer tools and all the other stuff that you normally have. So yeah, state changes can be tracked and played. So why React and Redux together? So essentially how you use them together, the React components get their properties from the Redux store that has the state. So just think of Redux with the state, React components are just rendering that state into something that's on the UI in the DOM. So the components, React components, just like the DOM, reacts to a user input, click or button press or whatever, and emits an action, either directly or indirectly. We'll kind of talk about that, why it's stated like that later. But then Redux handles that action from whatever that view generated, and then applies it, and then the reducers handle it and mutate that state, change it. And then with that state change, any potential React components that are around that are listening to that state change, they decide themselves whether they should update or not, and that's where that virtual DOM comes in. So they see the state change, they're going to say, here's the current state of the DOM, apply that state change, here's the new state. It does like a fast diff in JavaScript. If they're the same, it's not going to touch the DOM. If they're a little bit different, it'll update just the piece that's different and then change the DOM, so that it's only manipulating the DOM when it needs to, so that it's as fast as it can be. And then React components themselves are mostly stateless, but because all the state, you focus on keeping that in the Redux store, one common place, so it enables a lot of these cool things. So terminology from React, you guys can see that okay? That's not too bad, is it? Kind of bright colors, the red's hard. So React components. So what I like to think of as a React component has like an Angular directive. It's about the closest thing that you have, so I'd like to think of it that way, because a component also has props, which in Angular would be like the scope, and the scope parameters that you define up at the top if you're going to do like an isolate scope. So you can see some sort of similarity there to like an Angular directive declaring the scope and having naming your variables and like what they are, type of thing. Prop types is kind of one unique thing. You actually are saying, just like if we program in Java or strongly typed languages, right? We have something where we can say, well, this is a number, this is a string, this is a ordered map, this is a linked list, whatever, right? So that's kind of one thing that JavaScript doesn't have. And so what React has done is these lists of the properties that this directive, that this component has, these are the types. So it's an instance of an ordered map. So that's like an ordered map class, like a type of object, number, function, and then you can say is required or not. You can just specify defaults, stuff like that. So that's kind of another cool thing. And that's we'll talk about that later too, as being like a reusable component, like a great way to make a reusable component, just like a function. You'd want to make sure that you're specifying exactly what that function signature was, so that nobody screws it up and uses it in a bad way. So render, that's another common one from. Anybody done any Backbone stuff? Probably nobody. Oh, a few. Good. Good. We're the only ones going through that. So render function being like you're taking that view and you're actually rendering it out to the DOM. So like anything that you have in a render function that's why you see the HTML code sort of embedded in with this JavaScript function. So how about So I know this is maybe a little bit different. Have you guys seen and used ES 2015? Don't say ES6.
Oh, it's 6, man.
Andrew turns into the Hulk when you say ES6. It's ES 2015. Smash stuff.
When you talk to, what is it, TC39 or whatever. Everyone else is ES6.
Yeah.
No, man, it's ES Next. I'm
ES,
sorry. ES Next.
ES plus plus.
ES Extreme.
So what is ES7 called if ES6 is now ES 2015?
2016.
Is it 2016? But how do they know it's going to be released in 2016?
They're trying to move it up
Is it
the faster release cycle.
I don't get it.
Is 2015 really released?
Yeah.
Yeah, that's the thing. So that's part. I'll talk about the stack that we're using with this, but you know, with the whole using Babel, it's going to compile back down to whatever, right? So yeah. So yeah, so you got a little bit of JSX. That's the JSX magic there. So you know, it looks similar to HTML. Got some funky stuff there. It's kind of like, I like to think of it like a templating language. Somebody probably shoot me for saying that, but I like to think of it like that. So just like Angular templates, underscore templates, whatever. They feel like it's the same type of thing. You can pull them out in a file if you needed to. So yeah. So this project does use ES 2015 syntax stuff. So if there's anything there that's funky, like can talk afterwards or something and kind of
Is
figure it out.
static, is that 2015 or is that 2016?
That's 2015.
2015?
Yeah, you can get the classes.
Right, Redux. So that was sort of React terminology. But I find like because like React, you wouldn't. I mean, you could use it on its own, but like you almost always pair. If you're going to do a full app, you're going to pair something with it. So it's Flux or Redux. So but I find it's useful to understand like action. Is that a React thing? Is that a Redux thing? Because like if you see a tutorial, you might see like everything in there. And you're like, well, I don't know what's which. It just sounds like that's React. But I want to know, like, did Redux add that? Like, if I swapped Redux out and put Flux in, like, what would Flux call it? So that's why I feel like it's good to have the terminology kind of know where it comes from. But so there's an action. So an action is something that's emitted and sent to the dispatcher. An action creator, as you might imagine, is just it's just a simple function that gives you an action. So having an action creator is sometimes handy to be able to have that action as a function that you can pass around and stuff. So there's some other uses for it too. The dispatch is really taking that action and applying it to the store. The reducer takes the action and then mutates the state from it. And then the store is where all the state is at. So I just kind of threw up some sample syntax. I got the path there in our code base. Don't get mad at me if that changes because we're coding it like crazy, so maybe it'll change, but for the most part now it probably won't. But yeah, so like just simple, you're trying to think of them as like the most simple actions that you get for us. And I need to talk about some of the sort of T-sheets, the terminology there too, before I get too much into this, but we'll hit this again too later. But basically, you kind of see the comments in gray against the gray screen. Actions, reducer, so you have that distinction there. So the actions don't have to really do a ton. Most of your work might be in job codes, but here we're actually calling out to a utilities file, so we don't have, so that when you see your actions and reducers together, they're not, you don't just have like a gigantic huge file. You can sort of split stuff out. Like we all know what we're supposed to. So this is kind of a way to show the data flow and how it goes within a React Redux sort of system. So this is a part of our project too. So we're using the T-Sheets API, doing some actions to a timesheet in their terminology. A timesheet is, of course, what you can track start and end date, just tracking tasks. Everybody kind of knows what T-Sheets is, right? It's just time tracking sort of thing. So from action creators, using a web API. So we actually use Redux Thunk for this. Don't worry about that. And we actually are going to hopefully in another presentation kind of go over that because we're trying to figure out for ourselves how to use it perfectly, right? So the action creator creates an action, then goes through the dispatcher in a callback, and then hits the store, which then the change events from reducer down, the views see that change, and then fed right back into when the view renders, something might go do the next action. So that's that one way. So I mean, that's, you know, you have going in, going out. You don't have to worry about, like with Angular, you know, you might be able to have a bunch of things kind of hooked into something and changing, and you have to tell everything else to watch it. So it's kind of an interesting philosophy. So when you put React and Redux together, there is a React Redux package, of course, on an NPM. So what that really does, there's more stuff that it does, but for our example today, is it's as you can imagine, React to Redux, we need something to take that state that's in that store and tell the React components about it, right? So we have this connect that says, like the function says, map your state to your properties, and properties again are kind of those, like, think of it like an HTML elements attributes, things that you're going to pass in to it. So mapping your state to properties and mapping dispatch to properties. So dispatch again is where the actions go. So we're taking a couple things out of our state, and then a few of the actions that we've defined in other files, like actions you can take on timesheets, actions on a time card, actions on job codes, and gluing them all together and saying, okay, time card view, you have access to all this stuff, go ahead and do your stuff. So, yeah, so really that's kind of where it comes together. So like I said, we kind of wanted to go through like our process that we went through to design an app using React and Redux. So first step was, of course, get our requirements. What do we want to do? What do we want to make? You know, we're keeping it pretty limited scope because, like any small project that has iterations, you know, we're going to go through this and then we're going to come right back up and keep looping on it. So we wanted to find a pretty minimal initial thing that would allow us to kind of exercise some of the stuff we'd learned. So first, what the heck do we want to do? Get some little mock-ups in UI, which really is just writing on the whiteboard for us. And then, based on that, design your state tree. That's the heart of this Redux app, is this state tree. So we know what our UI looks like. What kind of stuff do we need to store and have available so that all the different pages can show what they want to. And then, how will that state change? So that's defining our actions and reducers. And then once we know that, so there's no React at that point still. Fourth part is where you bring in the React, like which UI components are going to call which actions, and how are they going to change that? Which actions are they going to call to know how it's going to change state? So our app requirements. So we just want to make a time tracking web application based on the T-Sheets API. We just want to build a time card page. So the concept of a time card is like your current timesheet. So timesheet, like if you look at the T-Sheets API, timesheet is like one of their first level objects. Time card is typically an alias that they have for like your current, like on the clock type of thing. Like I come in the morning, I'm gonna hit clock in. It's my time card, even though it's technically a timesheet behind the scenes. It's always those, you know, the sort of product and marketing terminology of something versus. So we tried to adopt that same sort of thing within the apps that we made too. So we just want a time card page so we can clock in and out of a timesheet. So clocking in, setting the start date, and then it's just running, right? And then stop, clock out, that sets your end date, and then that timesheet is essentially complete. So that's about I think the simplest I can describe T-Sheets application that would be minimally functional. So we have other things that we kind of defined, but as we've only been working on it for about a couple weeks now, we're kind of starting with the time card. But we eventually want a timesheet list and the ability to edit individual timesheets. So the app UI and pages, so like I said, basically 3 pages, time card page, list page, and add and edit page. So that time card page should have a clock in and out button. There's the concept of a job code. So like I think of it more like I'm doing client work in the morning. If I'm going to be working on T-Sheet stuff, I'm going to be going into my own program and picking T-Sheets and the project I'm working on and hitting start and just playing, and then at the end of the day, you know, billing, right? So same. A job code is just like that. It's like picking what you're working on. And notes, because you can write notes like what you did for the day, and then we want when you're on the clock that your time like shows, so you expect to see that how much time you've been working. So we wanted to give, at this point, wanted to kind of show what we have. So instead of, we're kind of sort of cheating, I guess. So instead of showing you what we designed for mockups, since we kind of have the app, we figured we'd just show you, you know, our rudimentary thing. So, Andrew.
So as you can tell, it's rather bare bones at this point. There's not much going on, sort of in the UI. And over here on the side, on the right side, is that sort of taskbar he was telling you about, that tells you what state you're in and the actions that have been performed. So I'm gonna go ahead and reset the entire app state. And so fetch job codes is a function that we can call, and that went out and called a API request to T-Sheets and got this list of job codes that is for this current employee. As you can tell, this got the response called set job codes, and then this parent IDs is just sort of a way to keep track of this sort of nested state. So we're just resetting them all to 0.
So
yeah.
what is that bar that you have there?
Oh, the bar on the right. So here I can show you this is a list of actions that have been performed, the arguments with that action, and then the state after the action was performed. So what you can do, let me go ahead, reset it again.
So yeah, so notice he's
Call-
not like reloading. That's not like a reload. That's like, it's actually unwinding all of the state and putting you back at the
So
beginning.
what I can do here is actually undo every single action that we did. So the set job codes action, we can undo and unset it, and actually go back and reset the job codes.
It's part of the Redux dev tool.
Yeah, this is just sort of a drop-in thing that Redux has.
Yeah, if you're gonna have a project, you put it in there
You
because
can take it out.
That's what that
during
single
production.
state allows you to do. You know. So
And so as you can see, if I went in, that set the parent ID to a different thing, so it filtered that list. I can unset the parent IDs, and it's good to go. So when you say select one, it will it'll highlight it'll highlight the parent of the job code you selected. So and then what you can do, you can clock in. It just sets the start. That's really all that a clock in is. It set the start, and also will set on the clock true in the object. As you can see, it said update timesheet. The payload, it just has a start on the clock true, and it just makes sure that it knows which one we're updating. And you can undo that. As you can see, redo it. It's on the clock again, and we built in this little sync thing, so it'll actually go up when you press sync. It'll do a post request to the T-Sheets API, and actually if you go to T-Sheets right now, it'll show me as on the clock, and clock out, it resets it, and you can sync, and it'll actually do a put request.
yeah, that's
So
kind of how
then-
the whole thing goes. It's your clock in is creating the record initially, a post, and then when you clock out, you're actually just adding an end date. So that's a put. So it's the two. Sort of things.
So really all we're doing here each time is we're updating the timesheet depending on what we're doing, and it's easy to see what we do here. Oh, that's set end to whatever, so we can undo that action, undo all these, and it'll show us before we actually reset the state. So there's the end, and then this resets which one the time card is looking at, and
So it's
so
crazy,
it's
crazy
a really
cool.
great way to debug. You can replay states over what happened, and it's with a single one-way data flow. It's really easy to tell what went wrong and to track it down.
And that's all because you have that single state. It enables this sort of thing to happen. I mean, I'm sure maybe you could come up with other ways to do it with other applications, but it makes it super easy. So that state there, that is the representation of our total state for the whole app that we are storing. And for the most part, I mean, we have some applications where we may store like some internal state inside of a React component, but for most purposes, you would almost never want to do that. There's kind of a few things that we're, specifically with this app, we might. But yeah, so like you have that whole thing, so you can see exactly what happened. So like today we were debugging some problems in some of our actions that we had. So it wasn't like, oh shoot, we have to go reload and try and recreate exactly that state that we were at, which we all know it's like, well, shoot, what did I click first? What did you click first? Do you have a log? No, we don't have a log. So this is like your running log. Like we wanted to figure out what was going on. So we just went back, like, oh, the payload was missing the ID. Shoot. So then you go fix it. And the other thing with this, like, you can fix the code. and it's hot reloaded. So almost everything can be hot reloaded. So
It's not perfect.
not perfect, but it's
getting
most
there.
for the most part it works good. So then you can just, if you're in that state, you hot reloaded your code, you can continue on and see if it worked better. Maybe you fix the bug or whatever. So
Hey, Jeremy, how do you
Yeah.
share that state with another guy?
I'm not sure if they
No idea.
have that
I don't know.
yet.
I would-
It's not built into the dev tools, I don't think, but that's a pretty simple thing to do. Is it keeps track of the list of actions, and you can just send it over.
You could
Um,
export it and then load it in based on cloud.
Yeah, that's what I would think. You'd like maybe write some middleware to save it down, like
Yeah.
because you could save that same state to like IndexedDB or something, or
You could do that, yeah.
yeah, and then like yeah.
Oh, sorry.
Like-
I was just gonna say, it seems like that'd be an amazing way to, dump your application state out for debugging.
Yeah.
Yeah, you-
Production or like, can you do stuff like this on the server where you build state ahead of time and then send it up?
Right.
And continue from that at all? Or
Right. I'm sure.
Can you?
I'm sure you.
Well, the people who will do like the server rendered stuff, they'll initialize the state on the server, send the first rendered page to the user, and then sort of bootstrap it in with the initial state.
But I know like in the app that we're making for T-Sheets, one of the things that we added in that's something from their production app too is the whole send feedback. And what that does is like we just dump everything. We got logs, we've got database stuff, but we don't have exactly the app state. Wouldn't that be cool to like have that all wrapped up in the dump that you emailed or whatever, and then you loaded it in? Like, yeah, oh yeah, that's the app state. That's why that's wrong. Exactly right there. Not like just got a bunch of data behind the scenes. So yeah, no, that'd be cool. That'd be a fun open source project. All right, so now that you've seen the app, it'll be a little easier for us to talk about like how we would design the store, and this will make a little bit more sense. So this is a lot of small text. I don't want to bore you too much, but so like you saw, let me just flip over. So like you saw with our store that has the state, this is essentially what it is. Actually, I'll go down to the bottom. We have a time card that is an ID of the current timesheet within the timesheets list. It's not expanding. There we go. So then we can go in and we can grab it and see that is the current time card. So whatever one, I think this one, that should be on the clock. True. Yep. So that's the current one that matches that state right there. And then job codes, because we have that list there. So then we keep track of that list of job codes that we have that we fetch from the server. Which there's a lot of them because this is like a super debug environment. So, and then parent IDs. So this was the one kind of. So I guess really with designing the state, there was kind of two decisions that seemed like non-trivial to make. Like we knew if we had a timesheet list, just store a timesheet list. If you're gonna do a job code list, well, you just store a list of job codes. But then what do you do when you have a time card page that needs to remember, like we wanted it to remember, like if you came in here and you picked that, we would want it to remember that, like if even before you started your timesheet. If you went and wanted to look at your old timesheets and do some other stuff and then come back, we would want that remembered, because if you click that, we're assuming you have an intention of clicking that, we better remember it so that you don't get mad and feel like every time you go back to the page you have to find it again. So how we designed that in the state, we figured we would have a currently selected job code for each of the pages that we were planning on having this on. So all it stores is it's going to be an ID. It's 0 right now because it's like parent level sort of thing, and I think I'm behind by a couple clicks. But so then we actually know how to display it. So that was kind of the one little thing we kind of debated on. I weren't really sure how to do. And then yeah, and I think the only other thing that was kind of something that we debated about was the time card, whether that should contain a full timesheet object or just a reference to that timesheet within the list. So we ended up, we're still playing with it, but we decided to just put an ID so that we didn't have duplicate data hanging around too much. So that's, so the other thing, so when you design your state, that's where opportunity to talk about immutable data and immutable JS, which is another Facebook project. So we know that React is designed for efficient DOM by using the virtual DOM, doing a diff, and then telling what you want to update, right? So, and we know Redux brings this common store that has all the state that then React connects up to. So if we can take that Redux store and make it into an immutable object, meaning that it can never actually be changed in place, it can only be replaced with, components of it, parts of it. Because as you saw, the store is, you just think about it as just a JSON object. It's got some properties. Those have some data underneath, some arrays, some maps, things like that. So if we can make that store as an immutable object, then when we are in our React components, we can just look at the data and we'll know exactly if it changed, because the only way it could have changed is if the reference is different. And then we don't even have to do the virtual DOM comparison, because it's actually, there's a component within React. Within a React component, it's a method called should component update. Yeah, and if that, it's like a way that you have to short circuit building that virtual DOM, doing the diff, and then determining what's going to be written. So if you use immutable data structure, you can then in that function just check, and it's a super quick, easy, fast check. It's a shallow. It's not a deep watch like it would be if you didn't use immutable data. So you can actually just go in, and if the reference changed, you need to update something, then go ahead and do the rest of the virtual, because the virtual DOM and the diff, that obviously does take some horsepower. You got to do something in JavaScript for that. So this is even going a step further on performance. So even though React its performance gains are mostly attributed to the virtual DOM and computing the differences before you actually write to the real DOM, you can short circuit the whole thing if you use immutable and just look at reference, which is a super fast, easy, shallow compare and everything. So our starter kit that we picked did not have immutable in it, but that was something that we wanted. But it had, when we were kind of evaluating our different starter kit options, that was one of the things that we put in right away. So our store kind of showed it, but this is sort of given immutable JS. I'm sure from all of our computer science classes back in school or whatever that we maybe recognize some of these as being names of official big heavy Java looking data structures. But so ordered map being key value pairs. So number being like the timesheet ID, and that being the actual object itself. And I think actually these are strings. Might be right. I'm not sure. So maps with the list. So we basically saw that kind of with the thing, but the Redux dev tools know how to render the mutable stuff as like nice human readable stuff, unlike the Chrome dev tools, which you got to figure out a way to do that. Like if you dump a data structure that's immutable, it's a bunch of garbage. So we still need to figure that out. But it shows up fine in the dev tools, or in the Redux, the little dev sidebar thing. What's it called? What's the name for it? Is it
Redux dev tools.
Dev tool. Okay. So it shows up there fine, which for the most part, that's where you're going to look at defined state anyways. So it usually isn't that big of a deal, except when you're down in components and you're like, what is this? That because you're going to get a slice of that immutable data down in your component. So it can be a little tricky. So I think that's something we still need to investigate and figure out. There's got to be somebody who's working around that.
Using immutable JS is not required. It's just
Nope, it's just
you can
it just gives you that extra chance to have
enforce
super
it
fast.
versus
Yep. Instead of by convention, by enforcing it. Yeah. And we wanted to sort of force ourselves to do it instead of like just, oh shoot, I forgot, I accidentally, maybe I didn't realize I was, replacing something or overwriting it. So instead, like explicitly force it, which seems to fit pretty well with the whole pure function paradigm, and make sure that's going to happen. So so at that point we had our state tree done. We're like, okay, we're ready to start coding. So we sort of just went out and searched. We used the React Redux starter kit. Not to say that's better than any of them. That seemed like it was minimal enough, but had the stuff that we wanted, so we could extend it. It had some good. You had Webpack, has Babel, and we just added immutable JS. And it also already had Redux Thunk, which now it's the second time I've mentioned it, but that's what we're using right now for our API requests to add asynchronous action creator type stuff. So it's not bad. been pretty happy with it so far. So we got the state sort of all modeled for our app. We know what we need to store. So now, like, what kind of actions? So realize at this point there's no React yet. We did first step was the UI, figure out what we need. Second step was the state. So now third one is just let's build the Redux, the actions, and the reducers. So figuring out what kind of things are going to happen from our app. How are we going to want to change the state? So updating fields on the timesheet, actions for clock in and out. Seem like they're pretty, click a button. It'd be nice to just have an action that was like clock in and out. Being able to get job codes from the API, that was that set job codes action that you saw in there. So essentially we call out to the API, get a promise back. When it resolves, we then call an action with the data from the API results. So you use that to just keep calling back actions. So then you can track that in the state. Syncing up a timesheets, like when you change it that you want to sync it up to the API. And then picking a job code when you're clicking through the parent-child sort of job code tree. So those are the types of actions. So at this point, you can code up your actions and your reducers and then write tests for them. You don't need React for this. So that would be if we were perfect ideal programmers, we would have done that and spent a week on it, but we kind of just blasted forward. But that's the nice thing about the concept of an action, the concept of a reducer. They're very easy things. They're very simple, relatively simple things, which we all know. Complex means hard to test, simple means easier to test, and debug and all that stuff, right? So it's kind of I don't know, I get a good feeling when if you write something that's simple enough where you think you can test it, but yet it does what you want it to do. So it's kind of a cool thing. So components call our actions. That's our fourth step in our design. So now we got the actions and reducers. Now figure out what in the UI is going to call which action. So that actually it's not too hard. I mean, you kind of are visualizing that anyways up front. So we sort of have, this is just sort of the nested structure that we have with our components. So I said at the beginning we'd have like 3 pages. We really only have one. It's the time card page. So when we call it a page, the framework we're using, or the starter kit calls it like a view component. It says it sort of splits React components up into a view component, a layout component, and then a component. I don't know why. So the view, what they call a view component, also known as a container component, also known as a smart component. I don't know. There's probably a million other names for it, and I'll talk about this in a sec. But time card view is sort of our high level. That's like the time card page. It's a container component. But all the rest of them are all stateless components, meaning that they do not directly get the state from the store. So we'll talk about that. But basically, clock in and clock out is a button. It's like a button component, or a React component. It's a button. Calls clock in and out action sort of indirectly, and then the managed list. That's what we're calling the whole parent-child job code thing. You get in there, and when you click one of them, it's going to go and tell what should be selected, where should I put this. And those are really the only actions that we have that are kind of functional, that Andrew went through there too. So I've been talking about these container components and stateless components. Abramov calls them smart and dumb. Other people call them whatever. I think there's he listed about 5 or 6 different names in this link here. It's a pretty decent read. It's not crazy long. So this is another kind of a good design pattern to follow when you're doing a React and Redux app. You don't have to do it, and this is essentially with React. You don't have to follow it like anything. You can just make one big React component that was doing all our stuff, but we know we should split things down into smaller pieces and things that are simpler and easier to test, like we all know. So instead of one big component, we think of things in terms of a container component and a stateless component. So a container component would be, that's going to directly talk with the Redux store, and it's going to be responsible for taking that state from the store and pushing it down into all of the rest of the stateless elements that are sort of underneath it as subcomponents. And that container is what emits actions, not the stateless components underneath. this high level component. So the way that in the React docs they talk about the state, they're like, yeah, here's the 5 ways you might be able to do it. But one of the ways they say is, well, just make a big, huge root component and have everything sort of stored there. That's almost kind of what Redux is. It's like that state, but it's not in a React component. It's in its own sort of outside thing, which I think that's kind of why that makes a lot of sense. But so the container component, it emits all the actions. So notice you're not going to really have actions. You're going to have callbacks from the stateless ones that come up to the parent, to the container, and it takes care of knowing which actions to call. So kind of like if you're looking at a component trying to figure out, well, should this be stateless? Should this be container? If it cares about the data and needs to fetch data or make sure data is available, it's a container component. So you separate that, and then anything else that's going to be rendered underneath it and make it a stateless component. And that's actually how we've designed our time card view page. So stateless, few dependencies. I shouldn't write no. There's probably, I don't know if that's. I'm sure somebody will call me out on that one. But you get your data and callbacks from the properties, which is essentially properties in React are like the attributes on your kind of HTML element type of thing, like the scope of a Angular directive. So you get them pushed down. So only callbacks and data. And remember that data is immutable, so you're not changing it down in the React component. It's only going to change by actions that are emitted from the container only. So then you end up with a bunch of these small stateless components that are then easy to test, simple to kind of understand what they do, at least if you break them down into small enough parts. So anytime you're talking about, can this component just be presentation only? Like what would be needed for this thing just to be shown on screen and make that a small component that we have. So yeah, got a couple links there, pretty interesting stuff. So yeah, I knew these were going to be a little small to read, but so time card view is this container component that we have. And essentially using Redux React router, we're saying /timecard equals this timecard view component. And that's essentially our glue from routing from, hashtag, routing, HTML5 push state, all that stuff. /timecard will go and instantiate that timecard view component. And so it does some stuff that I wanted to wait till I got another talk to kind of share what it does. But has to go and grab the list of job codes, of course, before the time card is shown, because you need to be able to clock in and pick up a job code. And its responsibility is mapping state and actions to the stateless component. So really all that's contained within this time card view is a stateless time card React component, where we pass down the timesheet, we pass an on clock in, and this is actually an action, a clock in action. So this is the property, but this is like a callback. So in ES 2015, I guess I should mention that too. Like I still get tripped up on some of the syntax too. That's creating a function, just the 2 curlies or parentheses, and then it's returning the clock in, and that clock in is actually an action. Same with on clock out, it's passing job codes in, passing the parent ID from our immutable job codes data structure. On changing of job code, so there's, this is a time card, we know there's a job code element in there. We're gonna say, pass that down. When that job code changes, notify me up at the very top. I'm the ruler of the page. I'm the time card view. Let me know what's happening. So then it'll call a couple. These actually are both actions again, but within a callback. So this is sort of all kind of self-contained. And then on change job code parent. So that's the navigation between like child and then back up to the parent and then back down to the child. Like I want to know about that too. So pass that down, and then that calls another action. So essentially, if you ever want to know how your program is affecting this state, it's coming from here. You don't have anywhere else to look. The stateless components underneath are calling callbacks, but they're all hitting stuff that's in this component. So it kind of gives you a, well, where do I look? Well, first look here. What's our state? We got the little debugger thing. Where's our state? What was our action that was called? Okay, where could that action be called at? Probably only one place. If we were on that one page, it's going to be called from in here. So it's just it's a really good debugging experience. So I kind of highly encourage just going in there and writing some bad code and letting it help you out. So time card view has a time card component within that. It just calls a job code and the clock in. Again, those are stateless components, just passing data down in, and then passing callbacks that it will call and notify when things happen. Same with the job code. We have like a generic list because we have other things that we're probably going to use that for. So we even pass an isSelected function, because if you remember in that job code list, if you select a child, the parent is also highlighted. It's like, you know, if it was 2, 3, 4, 5 deep, if you selected a child, you'd still want to see at that top level that you had something selected, even if it was 5 levels down. So we just pass in isSelected function that takes 3 parameters and will give you a true or false whether the current job code being shown should be highlighted as being like active or selected. So that was kind of a lot of fun to see. And then kind of boils down to the managed list, which that's a lot of code. Probably shouldn't have put that much code on here, but it's just designed to be a generic, you know, display a list that can have a parent-child relationship type thing. Render a button out. It has an on click that passes the value of it to the key, and it bubbles back up and gets handled, and then an action emitted that says, hey, you just changed the job code that you selected, and that's in that time card view, that very top level container component. So I'm almost done, I promise. I only got a couple slides left. So for reusable components, I kind of mentioned this earlier, where you have your component, you can say, these are the things that I'm passing in, and they are required, and here's the type of them. And then you get these beautiful debugger messages when you screw up. Like, hey dude, you should look in the render method of this component because you passed something stupid. You were supposed to pass an object map and you passed a number. So they're like, oh, okay, sweet. So it's kind of cool to have your your framework like, yeah, dude, you made a mistake right here. So I guess that's what other people get for doing, when you're in more, strictly type server-side languages, you're used to that stuff, which is just something we haven't really been used to a lot with JavaScript, where, if you're a JavaScript developer and you talk to a backend developer, they're like, how do you do what you do? Like, you just get this big old dump of crap on your screen when something goes wrong. Like, it still happens with Angular. I don't know how to fix that either. So my code always generates that. So this ordered map, that's an immutable thing, so we can ensure and guarantee that nobody's trying to like slip some mutable data by us. So make sure it's immutable. So what are we gonna cover next? So by next, I don't necessarily mean next time, because you get busy and stuff. I don't want to commit to that. But we've kind of been working on this. We wanted to talk about how to do asynchronous API stuff, because it's pretty important and has kind of caused a lot of well, where do you do it? You got actions, you got action creators, where do you do it? So we've basically done it with Redux Thunk and within our action creators, and it's some middleware that you add in that knows how to handle an asynchronous type of thing. And then when the asynchronous is done, you can call an action. But we're kind of still figuring out how to do all of the proper REST API calls and organizing things well. So kind of a work in progress. How to ensure that data is loaded. Like if you have a React component, like that top level view, like the time card page, we need all the job codes. How do we do that? Is that a Redux thing? Is that a React thing? And then there's this map dispatch to props, find action creator stuff that was kind of blew my mind a little bit. And then probably by next time we actually think, everybody's like, oh, your React component should never have local state now that you have your state in your Redux, but we think with tracking your time and having it count up from, if you clocked in, you have a start date to have it count up, it may be a situation where we use local state to kind of have a timeout that's just incrementing the time every second. So we'll see. Yeah, that's it. So that's us. Hook up with us on and I'll post the slides in PDF form on my blog, and I'll of course spam it out to the Meetup